In our last video, we reviewed the concept of implicit differentiation. Now we're going to apply it and solve a problem. Here are the general steps for implicit differentiation. Let's apply these steps to the following equation. This looks complicated, but if we follow the steps, it's just a combination of the chain rule and some basic algebra. Step 1. Let's differentiate both sides with respect to x. That means we're going to take the derivative, or d by dx, of the entire left side and set it equal to the derivative, d by dx, of the right side. Let's go term by term on the left side. So what's the derivative of y cubed? Notice the variables disagree. So we have to use the chain rule. The derivative of the cubed part is 3y squared. Then we multiply that by the derivative of the inside function. What's the derivative of y with respect to x? It's dy dx. Now do the same thing for the next term. The derivative of y squared with respect to x. Again, we'll need the chain rule, and we get 2y times the derivative of the inside, dy dx. Same thing for the third term. Use the chain rule. The derivative of negative 5y is just 5. But remember, we're also differentiating with respect to x, so we need to multiply by dy dx. For the next term, what's d by dx of negative x squared? Now here the variables agree, x and x. This is just the power rule. The derivative is negative 2x. Let's move over to the right side. And the derivative of a constant is 0. That was the calculus part. The rest is just algebra. Step 2. Let's collect all the dy dx terms on the left side of the equation and move all the other terms to the right side. In our equation, we have 3 terms with dy dx in them, and they're already on the left side. But this negative 2x term doesn't have a dy dx. So let's add 2x to both sides to move it over to the right side of the equation. Step 3. Factor dy dx out of the left side. All 3 terms on the left have dy dx as a common factor, so we can pull them out just like we're factoring out any other variable. Finally, step 4. How can we solve for dy dx? We can divide both sides by that stuff. And that's the derivative of our implicit equation. Now, what does this mean? Pause the video and think about what we did conceptually. This formula, dy dx, is our slope finding gadget. We can use it to find the slope at any point on our original equation. Here's the graph of our original equation. This weird looking graph is not a function. It fails the vertical line test. But with this formula, we can find the slope of the tangent line anywhere on that curve. So let's try that. Find the slopes of the tangent lines at each of the following points on the graph. To do this, we can just plug the x's and y's into our new derivative formula. So at point 2, 0, the top 2x becomes 2 times 2, which is 4. And the bottom becomes 0 plus 0 minus 5, which is negative 5. The slope at point 2, 0 is negative 4/5. Now, does that look right? It does. Now pause the video and try the others, and check that your answers make sense with the graph.